Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael, and in studio with me, we've got Zain and Shaun. And boys, if somebody needed to get in contact with us, what would they need to do?
For math homework help, call.
In Bakersfield, 636-4357.
Everywhere else, 1-866-636-6284.
Email dothemath@kern.org.
We're online at dothemathonline.net.
And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So, obviously, you boys are brothers.
Mm-hmm. Yeah.
And you're twins.
Mm-hmm.
And where do you go to school and what grade are you guys in?
So we go to Old River Elementary School and we're in 6th grade.
All right. Now, Shaun, have you guys been in the same class all the time throughout school, or have you ever been in different classrooms?
Ever since kindergarten, yeah, we've been in the same class.
Okay, so Zain, do you like being in the same classroom with your brother all the time?
Yeah, I think it's pretty nice because if I need help with homework, then and other reasons too. But
I was going to
yeah.
say that's a perfect thing right there. You always have somebody that can help you because you're actually in the same classroom all of the time.
Mm-hmm.
So you guys have been together for a long time. Obviously, twins have a special bond because of you guys being twins. You're going to junior high next year.
Yes.
Do you think you'll be in all of the same classes now?
No, I don't think
Yeah,
so.
there's going to be a lot of different classes, so I'm pretty sure not. But
Yeah.
So have you guys done like an orientation yet, or talked about to counselors like what classes you'll be taking yet, or is that coming up?
That's coming up, I think. We
No,
haven't really done that.
yeah, we haven't talked about the classes, but we took a field trip there to get an introduction to the school.
Oh, good.
Yeah.
Okay, and where was the field trip to?
Warren,
Junior high.
All right, so you guys will be going to Warren.
Yeah.
All right. Is there anything that you're looking forward to? Because you know you'll be in different classrooms finally, right?
Mm-hmm.
And in some ways it might be good. In some ways it might be like, oh, I kind of miss my brother being in all the
Yeah.
classes. But are there any other things that you're looking forward to when you go to Warren?
Well, one thing I'm looking forward to is being able to choose a class that I'm going to. It'd be cool because I can choose something that I'm interested in instead of having all stuff that I'm not.
So have you heard about any classes yet that you think you might be interested in?
Yeah, there's this one called robotics. There's you learn about math and science and you build like robots. And there's another one called like a ukulele class where you can learn to build a ukulele and play one.
That's right. And Shaun, what about yourself? What have you heard?
Pretty much the same thing. I've heard all of them. I'm interested in both those two. And there's also like art. That sounds pretty cool. And yeah, there's a lot that I would pick.
All right, good. Well, you guys have a lot to look forward to when you head off to junior high. What types of mathematics are you doing in your classroom right now?
So we're kind of like doing some algebra. It's a little hard to explain, but it gives you like a word problem and you have to put it into an equation kind of.
Okay.
Yeah.
And you guys help each other with that, right?
If we need
Yeah.
help, yes.
Okay.
Usually, yeah.
Well, we'll do a little bit about that later on, all right?
All right.
All right, before we get to any of that, let's first take a look at today's Math in the News. All right, there we are, highlighting our 20th season of Do the Math right there. A couple of snapshots from the past, including year number 1 right there in the center. And this is the final show of our 20th season. And for Math in the News this entire month, we've been taking a look at people behind the scenes that you don't see on a normal basis, and you probably haven't seen them in 20 years. If you've been viewing the program 20 years, I decided it's time to see you guys and find out the people that make the show go. So our final contestant is
Oh, boy.
John Lenko.
There it
And John, what is your role with Do the Math?
Well, my title here is coordinator, and it's my job to coordinate the technicians that help put on this show. So I have the privilege of working with them, and I have the privilege of directing the show, and currently floor directing the show out here working with you.
All right, so coordinating the technicians, that means working with Brian and all of the students that we have working in the back.
Right. We actually have split the responsibilities. You're responsible for the tutors that we see and the content that we see on air, so you coordinate those folks,
Right.
and I work with all the people who are behind the scenes and the producers who put the show on.
All right, and the reason I wanted to save you to the last interview, is because you have been here all 20 years as well.
I have you and I.
Yeah, so you and I have been here since day one, but I would say that you were here DTTM, right, before Do the Math, because you worked for the Kern County Superintendent of Schools before the show started. So talk to us a little bit about how did the show come to fruition? How did this whole thing come about?
The show grew from a need. Students let us know that they needed help with their after-school homework. A lot of students were going home to an empty home and they had no one to help them with their homework. After-school programs 20 years ago were not as robust as they are today. So students were going home and they needed some help with that. They needed tutoring. So we based the program actually on a service that was being offered in San Diego at their county office. We went down and we looked at their program, and then we grew a program based from that here in Kern County.
And I remember seeing a clip of that program down there, and we saw it, and we were
Excellent
like,
show. Excellent show.
yeah, we see what they're doing, and
Yeah.
we can do something like this.
Yeah.
And I'm not even sure if that show is still going, but I know that this program has evolved quite a bit over
It
20
has.
years.
It has. It's grown a lot.
So at the beginning, we didn't have students working here, or we didn't have as many.
Well, correct.
So how has that been working out?
We've always used students in the production of our show. We've not had as many on-air student guests as we have now, but we've always incorporated students into the show, and it's been our responsibility and our charge to give them a real-world working experience. So it's very rare that you have an opportunity to work in the studio, multiple cameras, a
Right.
live program like this. So we wanted to make that a real-world experience for those students, and we've had a lot of students come through the program, and some who have made this their career as well. So we've placed students at network level who've come through our program here, so we're very proud of that.
Well, I was going to say, you can't find many places where you're 14, 15 years old and go, hey, this is something I want to do. Have the opportunity to try it here, get your feet wet, and then move on. Because I know there have been a lot of people associated with the program over 20 years that have moved on to other things in this field.
And we set,
from here.
we set the bar very high for those students. Their expectation is that they will be performing at an adult level. We provide all the training for them, we provide all the support for them, but then they step up. And everyone throughout the years has always stepped up. I'm always so impressed with that. We've even had students that we've grown into positions that were formerly staff positions. We didn't know if a student could do that. For example, produce the show. You know, Mackenzie was our first student producer of the show. She grew into that. We've had students direct the show. We've had students do every technical position on the show as their talent and their ability warranted.
Yeah, and you know what, we'll throw a little plug out there since Mackenzie was the first one. She has moved
Big
on
Mac.
to
Big Mac.
operations director for Logic Film Company, a film company here in Bakersfield, but got her training here with Do the Math.
And you're always welcome to come back, Mac, anytime. Despite what the boss says, you're always welcome to come back.
Yeah, I had to let her go at one point, but anyway. So what is something that comes to mind? If somebody says, you know, John, you've been with the program for 20 years, you've seen a lot of things evolve and a lot of things change, and, you know, what is one of the best things you have seen this program do over the 20 years?
It's done a lot of things. One of the things that I think I'm most proud of and proud of for all of us is that we've listened to what the show has wanted. And by that I mean that the show has evolved. When we had students at home who needed their help, talk to a tutor and be helped that way, we had banks of tutors here. We would do, if you remember, between 60 and 100 phone calls a day. And those phones were well packed. Then as programs came online to their school districts, okay, then we transitioned the show. Let's go out to those school districts and see what those students are doing in those programs. So we had live shots. Willie Lowell and I would go out, and producers would go out and do those live shots, and we'd be at those after-school programs. Then when COVID came about, we moved some of those programs into the studio. Also STEM, STEAM, that all came to be such a part of mathematics, and math is such a part of all of that. We've rolled that into the show. What are some career training programs that are out there? We've rolled that into the show.
That's a big
I think
part
this
of it
has
now.
been one of our most robust years for content on the show.
And I would say even focusing on that A in STEAM, we've done a lot with the arts this year, including the Panama Music Department coming in every month, the Bakersfield Museum of Art coming in every single
Great
month. So
guests,
we have
great
incorporated that A into what we've been doing for the 20 years and making sure that is as solid as everything else.
You bet, you bet.
So you've got 20 years under your belt here.
Yeah.
And so how long do you think you're going to keep going with Do the Math?
Well, I don't know. I don't know if I can outlast the host or not.
Well, easy now. We're both tied at 20.
But I got to tell you, Mike, I'm so excited about what's coming, what's coming in our future. We've got such great opportunities to grow the show, and without tipping our hand to our viewers, we've got some great things coming in the next season and the season after that.
Oh,
so I'm very excited about where it's going, the engineering and some of the guests that we're talking about lining up for the show.
Right.
Just really, really neat. Sky's the limit for this, and I'm really proud of that.
Part of my duties is making sure we get all of those guests, what we're going to be doing, features and things like that. And every year, you guys come to me and go, hey, this is what the office would like to see, or they like what we're doing, and we kind of expand on that. But every year, we want to keep it fresh.
You bet.
Right? And
You
we
bet.
want to keep it going and evolving and make sure that it is something that students and adults get benefit from watching.
And this show gives us a great vehicle to do that. You know, we can go and learn about how's math used in a bakery, how's math used at the drag strip, how's math used in Major League Baseball.
And we're going to take a look at that
awesome.
later on this afternoon, a little
Cool.
snippet of that. But
Cool.
yeah, because I always ask students, well, can you think of something, a profession or something that you would like to do where you don't have to worry about doing math? Because a lot of kids, I don't need to know all this math, I'm never going to use it. Fine, bring something up. Let's hear about it. Well, guess what? This is how you have to use math.
That's a setup.
Which is why we have all of these, every single week, we highlight a different business or industry. And I think that is a big part. And then having, you know, like Shaun and Zain and this, you know, having kids in the studio so that kids can see other kids working on problems where it used to be just us tutors all of the time. I think is a great benefit for them as well.
You bet, absolutely.
And
Absolutely.
before I let you go, I do want to, because you are an employee of the Superintendent of Schools office full time, just to pass along a big thanks to our Chief of Staff, Steve Sanders, and our Superintendent, Mary Barlow, because without the support of those two, the show really doesn't happen.
Absolutely, and you know, without the support of all the underwriters that we've seen throughout the years in the opening and closing credits of our show,
Right.
They do more than provide funding for the show, and that's a rare program, but they've contributed to the creation of this program for all those 20 years, but many of those have been on board for the full 20 years. And they've become collaborative partners of ours. They do much more than just provide funding, they provide story ideas. We've been to many of those businesses and many of those partners. They've showed us how math is used, and they're just super supporters, and we couldn't do the show without them. So thank you all. Thank you very much.
And they know who they are because they've been with the program for many years.
Yeah, great
And,
supporters.
we've
Couldn't
got
do it
even
without
some that haven't been here all 20 years, but they've been here for a long time since they've
bet they have.
caught on.
You bet they have.
And they're continuing to go. Any last words before I let you go?
Well, thanks to you, Mike. Thanks for all you've done for us.
Hey, you know what? This is a side gig, and I love it, man. I'll tell you, if I didn't like doing it, I wouldn't show up. You know, people go,
Mr.
"Oh,
Math.
you work a lot."
Mr. Math.
But we do this because we like doing it also. You know,
It's
I mean,
a lot
if it
of
was
fun.
a chore
It's an
and
awful lot of fun.
torture, I would be like, yeah, you give it to somebody
I'm
else.
very
let them
proud
do
of this.
it.
We're all proud of this. So.
We all love
Thank
it.
you.
That's why we're here. That's why
Thank
we
you.
have 20 years, and we'll
you
have
go.
21 next September. That is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. But today, the 23rd, today is the final live broadcast of Do the Math for our 20th season. Rebroadcasts, reruns, whatever they call them technically, will be on KETN and Spectrum throughout the rest of the year. YouTube, as always, whenever you want to view a program, maybe you remember seeing something that I remember seeing that business or that person on there, or I was on that day. Want to go back and take a look at that, just go to our YouTube. All of the different social media things are at the bottom of your screen periodically throughout the program. But it is time now to get the boys back to work. So we've got a couple of Old River boys from 6th grade, Zain and Shaun. You guys ready to do a little work?
Yep.
All right, head on over to the board. And Mickey is here with us. How are you today, Mick?
Oh, just heading into the studio. I was about 30 seconds late, so I had to come in a little later in the show.
We were busy, man. You take your time right there. All right, so Mick, here's your first question. So we have Shaun and Zain in studio with us.
Okay.
Do you know who is who?
Shaun and Zain? No,
Yeah,
don't
I
swap
can believe
places,
that. He
okay?
gets it right
Do
over
not
there.
switch. I like the shirts. We're good.
I'm going to ask you that in about
that.
30 minutes and then see if you remember that later on. All right.
Give me some help if he asks, okay? Help me.
Yeah.
All right, so first thing we're going to do is we're going to work with some fractions, okay? So I put a line down the middle of the board for you boys, and what I would like you to do is on each of your sides, draw a horizontal line from that center out. So you're going to draw a line going across to split your into a top half and bottom half. All right, so go ahead and do that.
So we want to split the board into fourths.
There you go. Perfect. All right, so we're going to look at 4 different cards. All right, so I'll read them, and then Zan, you'll do the first one, and we'll just kind of alternate like that. All right, so up on your top box, let's put Frank. And you don't need to write it very large because you're going to have to do some work up there also.
Yeah.
All right, so you can write Frank up in the first one. And let's take a look at the problem together. So eventually we need to figure out which of these cards are truthful and which are not. All right, so if someone wanted some of my burger, they should have asked. I might not have given him half, but I would have given him just a little less, say 2/3 of the burger. So Zan, what do you think they're saying here? What do you think they're asking?
Well, I think what they're asking is that Frank is, if he was giving out some of his burger, he was saying that they might not have given him 1/2, but instead 2/3 of the burger.
So he's saying he would have given them half. I might not have given him half. I would have given him a little less, 2/3. So he's saying that 2/3 is less than 1/2. Do you know how to write that?
Yes.
So 2/3 is less than 1/2. So can you work yourself through that and let us know, is that true or not?
Okay. Well.
And if you need some help, Mick is right there for you.
Okay. So the first thing I can do is find out what least common multiple, I'm pretty sure, of these two numbers, which 3 and 2 would be 6. So if we did 2/3 times, I don't actually need that, so hold on. Times the 6 right here, I could get 12/18, which I don't know, seems like a big number, but then we multiply 1/2 by the 2 6s. And then what I would get is 6/12.
Now, Zan, I'm going to stop you there for a moment. So when I compare fractions, right, I'm going to take over this top right box here if my pen will work. So when I turn something, let's say I have 1/2 and 2/4, right?
Yeah.
Are these the same amount?
Yes.
How do you know that?
Because I might have read something wrong here, but 1/2 times 2 is 2/4, because if you multiply 1 by 2, that's 2, and 2 by 2, that's 4.
Perfect. Okay, so you said you want to come up with the least common multiple, right? And you said that's 6?
Yes.
So when you do that, your goal is to turn both of these denominators into a 6.
That's what I forgot. I'm
Okay,
sorry.
so why don't you go ahead and erase it. Let's do it one more time. You have the start. You know exactly what to do. Let's just try it one more time.
Okay, so then if I wanted to get 6, I would have to do 2/3, and then to get 6, 3 times 2,
Okay.
and then you can do that as well. So then you'd get, I don't know what happened there, but
You're good.
4/6, and then for 1/2, to get 6, you would need to multiply by 3, as you can see right here. So right here would be 3/6.
Aha, so if we
Okay.
were to change these fractions, so instead of 2/3, what should I have?
4/6.
Okay, so let's erase 2/3 and put 4/6. And then instead of 1/2, what's our new fraction that we determined?
3/6.
Okay, go ahead and let's change that one out also. Now that they have common denominators and they have the same size pieces, essentially 6 as a denominator means both of these units are split into sixths.
Yes.
Is 3/6 still greater than 4/6?
Well, now looking at it this way, you can tell that 4/6 is larger than 3/6 because 4 has more value than 3, and they both have the same denominator.
So do you think Frank is correct by saying if he would have given less or 2/3? Is that a accurate or true statement that Frank made?
I do not think that Frank made a true statement.
Aha,
because-
well done.
Yeah, so let's put a slash through that sign, that less than sign,
Oh, sorry, this one.
because that's not true.
Yes.
All
So
right.
should I rewrite it?
Well, just leave it like that. So we
You're
know
good.
that
That's
Frank-
how we indicate in math that this is not a true statement. It is not correct.
Yes.
All right. Sean, go ahead and erase all of Mickey's work up there, as lovely as it is. We'll move on to the next one.
It's okay. They call me the Da Vinci and Picasso of fractions.
Yeah, that's
we got
nice.
this.
Here we go. Something else of the fractions, but here we go. All right. So, Sean, here's yours. So this is Lori. So go ahead and write Lori up on the top there. Lori.
I was just about to ask, how are we spelling Lori today? Okay.
All right, here we go. I can't say someone ate half my burger because they never give any to the cheerleaders. I did notice about 2/3 of the bags looked open though. Maybe even more than that. It might have been as much as 4/6. So, what do you think Lori is saying about the 2/3 and 4/6?
So what I think she's saying about 2/3 and the 4/6 is that she noticed that there's 2/3 of the bags open, but she thinks that there might be more than 2/3, which is 4/6. So she thinks 4/6 is larger than 2/3.
Ah, okay, let's go ahead and show that using mathematics only, right? The nice thing is we're taking English and turning it into math.
Yeah.
Math is a universal language.
So she's saying 4/6 is greater than, and then 2/3, right?
Correct.
Yeah, yep.
Okay. 2 over.
All right, we're going to do the same thing that Zan did.
All right.
Do we think this is a correct or true statement mathematically?
I can't exactly tell right now, but if I find, like, if I turn this into 6, then maybe I'd be able to tell.
So if we have a common denominator, have them
Yeah.
both into equal sized pieces?
Yes.
Okay, go for it. Let's see
Okay.
where we go.
So 3 can go into 6 2 times, and then, yeah. So basically you're going to multiply 3 by 2 to get 6, and then since you do that to the bottom, you do to the top. So then you do 2 times 2, and you would get 4, and then 3 times 2, and you would get 6. So instead of having 2/3, it should be 4/6.
Okay, so let's erase it and put that in for our original inequality there.
And then
What do you think about that inequality? Is that an accurate or true statement? 4/6 is greater than 4/6.
this is not true because those are actually the same amount. So
catch.
you would put an equal sign.
Aha, but in this case, if we want to show that this statement is not correct, what would we do to show this is not correct?
You would put a dash right through this greater than sign.
Go ahead and put a slash through it. Let's show that. Perfect.
All right,
There we
on
go.
to the next problem. All right, Zan, you're up. Here we go. This one is going to be for Scott. So you can go ahead and write Scott.
Okay.
It wasn't actually 1/2 of the hamburger that was eaten. Mine was missing less than that. I would say someone ate 3/8 of my burger.
Okay.
So what do you think Scott is saying?
So what I think Scott is saying is that he's saying that 1/2 is he's saying that 3/8 is less than 1/2.
All right, so go ahead and write 3/8 is less than 1/2. And then we'll see if this is true.
All right. So then the first thing we would need to do is we'd have to find, similar to what we did up there, to find the common denominator. So we know that 8 is divisible by 2, and we know that 2 times 4 equals 8. So then, since I'm going to multiply this by 4, I'm going to have to multiply the 1 by 4. So then right here, you'd multiply that. 1 times 4 is 4, and then we have over 2 times 4, which is 8. So then 4/8. So he's saying that 3/8 is less than 4/8.
Is that correct?
Well, yes, I believe so, because 3 is less than 4, and they're the same denominator.
Perfect. Well done.
Thank you.
All right, so that one's true. All right, final one. Stella. All right, I never eat the stuff. I know that at least 1/5 of the players don't eat burgers either. I know that's less than 1/4 of the team, but that's still quite a few players. So what do you think Stella is saying?
So I think Stella is saying that 1/5 of the players don't eat burgers either, and she's saying that's less than 1/4.
So
she's saying,
1/5
yeah.
is less than 1/4.
Yeah, that's
All
what
right, so
she's
go ahead and write that up there. 1/5 is less than 1/4.
Let's see if Stella is correct.
Wait, oops.
Let's see if we can use math to prove it either way.
All right, there.
All right, what do you think we should do? How
All
could
right.
we prove this?
So you need to find a common denominator for these two. And I know that 20 is probably the least one, because you would do here 1/5 times 4 equals 20. So you're going to do the same thing to the top as you do to the bottom. Times 4. And then you would get 4 over 20. So this equals 4 over 20. So let me change that.
I like it. Good idea. Keep it consistent.
4. All right, and then let me erase this. 1/4, you can do the same thing, but this time you're going to multiply by 5. So times 5. So then you would get 5 over 20, and you replace 1/4 with 5. Oh.
There you go. 5/20.
Do you agree with Stella's statement? 4/20 is less than 5/20.
I would say yes, I agree, because the denominators are the same, and 4 is less than 5.
All right,
So-
nicely done. So we know that 2 of the people were not telling the truth. So Zan, did you find anybody that was not telling the truth?
Yes, when I did the problem with Frank, I could tell that he was not telling the truth because he said that 4/6 was less than 3/6, which is not true because 3/6 is less than 4/6.
All right. And Shaun, did you find anybody not telling the truth?
I did. Lori said 4/6 is greater than 4/6, but that's not true because of the same thing.
All right. Well, nicely done, boys. You've done some great work right there. And I know it's a little something than what you were doing in your regular class, but I know you've worked with fractions before and inequalities right there, so nicely done. You guys have each got yourself a meal courtesy of our friends at Grill and Burger, so congratulations on that.
Thank you.
All right.
You guys ever been there?
Yeah, I love that.
Pretty
Oh,
good.
excellent. Well, next time you go, ask for Lydia. Lydia works there all the time. She loves Do the Math, which is why she supplies you guys with free meals. And we certainly do appreciate Lydia and all she does for the program. We'll be back with more right after this.
The Earth's 2 poles, the Arctic and Antarctic, are so cold that for much of the year, even seawater freezes. Floating on the ocean, the enormous expanse of sea ice is at its maximum extent in winter and melts to its minimum in late summer. Sea ice provides a solid home for penguins and polar bears that can be many feet thick. Other animals live on, around, and under the ice. In fact, animals of the ice all depend on it in one way or another. Sea ice also plays a major role in the Earth's global systems. It keeps the polar regions cool and moderates weather and climate all over the world. But the steady climate we've enjoyed over the last 10,000 years is changing, and our warming world is melting polar ice at an alarming rate. Less ice cover allows more of the sun's energy to reach the ocean and warm its upper layers. A warmer Arctic Ocean could lead to changes in atmospheric and ocean circulation. Since we began measuring with satellites in 1979, the summer minimum area of Arctic sea ice has shrunk by nearly 50%. The 10 lowest extents have all happened within the last 11 years, and 2016 was especially warm, tied for the second lowest area ever. So why is the sea ice shrinking? Arctic sea ice is melting at an alarming rate because ocean and air temperatures are getting warmer. Here's how. The burning of fossil fuels emits carbon dioxide and other heat-trapping gases into the atmosphere. The heat absorbed by these gases is radiated back towards the Earth's surface. Then the ocean absorbs this heat from the air. As the ocean heats up, sea ice melts. A newer discovery is that even if sea ice area is the same year to year, sea ice thickness or volume is shrinking. This is because the warm water melts sea ice from underneath a little bit more every year. So sea ice volume is shrinking too. In 2016, sea ice volume hit an all-time record low. If we are to understand how much and how fast the ice is melting, we need to be able to accurately measure it.
All right, well, as part of our 20th season, we are excited to have different groups in every week. And this week, something a little different. Instead of having adults come in all of the time and explain a little bit about math to us, we have some students. All of these students are 6th grade students from Reagan Elementary School. And you guys all play the violin. And are you part of Strolling Strings? Is that correct?
Yes.
All right, good. So I knew I had some professionals. Even though you're young, you're very good musicians. So what I'd like to do is talk to you guys, first of all, a little bit about the violin and some of the music and the math behind it and things like that. So Dave, what will you be telling us about the violin itself first?
This part here is called the chin rest, and you put your jaw on it. This is the shoulder rest, and it's where you put your violin on your shoulder. And this is how you hold your violin. These are the 4 strings on the violin. Each string produces a different sound. These sounds are categorized as notes. This string plays the note A, this string plays the note D, this string plays G, this plays E. This is the fingerboard. The fingerboard is where you place down your fingers on different strings to change their notes. This is the bridge. The bridge holds up the strings so that they don't touch the fingerboard and leads the strings to the tailpiece. There are two different ways to tune a violin. Tuning a violin means to change the strings' pitches so that they play the note that they're intended to. One way is using the pegs. The pegs make larger changes in tuning. Another way is using the fine tuners. The fine tuners make smaller changes in tuning. Both tuners work by tightening or loosening the strings.
So Dave, I've got a question for you. How long does it take to tune a violin? Like if you get one, let's say a brand new one, how long would it take to tune it?
If it's badly out of tune, about a minute, but it should usually be around under a minute.
Okay, so it doesn't take that long, right? And once you get used to it, you can do it pretty quickly, right?
Yes.
All right, good. Ansh, I know that you're going to talk to us about the bow, correct?
Yes.
All right.
So the bow is used to play the violin. So the top of it is called the tip, and the bottom is called the frog. And at the frog, you'll see something that's called the screw. This is used to tighten and untighten the bow hairs, because when it's tightened, you want it to play when it's tightened, so all the bow hairs are parallel to each other, and it creates tension. And also, some bows are black, like Ronak's. So the black bows, they're unbleached, because these bows, they were black before, but then the people who make them, they bleach the bows so they're white. And unbleached bows like Ronak's that are black, they're rougher and they can carry more rosin, so it's like a better tone quality on the violin.
And how often do you have to have those replaced?
Mostly only if like the bow is bent or broken, then you have to have it replaced.
Okay, but you can pretty much go a long time, playing like a whole season that you're in school probably. You can just go as long as you maintain it properly and care for it, right? All right, nicely done. All right, Kate, what have you got to share with us? A little bit about math, right?
Yes.
Okay.
So when you're playing music, you need to look out for a lot of things. So when you're playing music, a lot of the notes will be commonly split in half of the previous, like a whole note, half note, quarter note, an eighth note, and it keeps going. There are also different notes though, like the dotted quarter note, dotted half note, or triplets. And each note also has a pitch. It could be A, B, C, D, E, F, or G. And after G, it goes through A through G for each octave. They also, when you're reading music, you also have to look for dynamics, which would be like the letter F, which is forte and means to play loudly. There's also the letter P, which is piano and means to play softly. There's also mezzo forte, mezzo piano, and more extreme piano and forte dynamics. Also, when you're reading music, each staff, which is the line of music, is broken into measures which have notes to make the music. Each staff also has a clef at the beginning of it, which depends which instrument you're playing. So it could be the treble clef, which is violin, alto clef for viola, or the bass clef for cello and double bass.
All right, so you spoke a little bit about the notes, quarter notes, half notes, things like that. So when you're looking at a piece of music, you need to be able to read that, and you need mathematics in order to do that, correct?
Yes.
And how long does it take you to learn, like some of the basics, to be able to play a piece when looking at it?
Well, if you already know your notes, then it could probably, you just look over it for a couple of seconds, maybe up to a minute, even if it's hard, and you can start playing it, and sometimes you might play a wrong note, but it's like sight reading, so.
Okay, well good, but it takes practice.
Yes.
All right, Ronak, what have you got to share with us this afternoon?
So there's many different instruments than the violin in the string family. The first one would be the violin, which is the smallest and highest pitched out of all the instruments. And the names of the strings on the violin is G, D, A, and E. And it's the smallest and probably the most commonly played out of all of the instruments. Then there's the viola, which is kind of like the violin, but it's a little bit bigger. And instead of having an E string right here, it has a C string, which is lower than the G string. So it makes a lower sounds than the violin and all. And then after that, we have the cello. The cello, you have to hold on the ground, and there's a stick that comes out of the bottom that touches the ground, and you have to hold it on your shoulder and play sideways, kind of like this. And you have to like, it makes the deepest sound it makes the second deepest sound out of all the instruments, and it has the same strings as the viola, which is G, D, A, and C. Next, you have the bass, which is the biggest and deepest sounding instrument out of all of the instruments in the string family. And it's so big, most people have to stand and play it. But if you have a really tall chair, I guess you could sit and play it. But during a concert, it's more commonly played standing. And it has the same strings as the violin. It's G, D, A, and E. And that's the end of the string instruments in the string family.
All right, so great explanation about the different ones and sizes. If you guys obviously play violin, how easy would it be for you to say to pick up a cello and start playing it, or is it dramatically different?
Well, the cello would be a little harder than the bass. If you wanted to switch to an instrument really quickly and you were good at the violin, I recommend going to the bass because it has the same strings as the violin, same fingering and all that. So all you have to get used to is just playing like instead of on your shoulder like this.
Playing with it down here and across like that?
Yeah.
All right, good. Well, I think you guys are ready for a number. Kate, what will you be performing today?
The piece we're performing is called Tango for Strings by Tom Lawrence.
All right, well, let me get the music up here for you guys quickly. All right, and here they are, part of the Strolling Strings from Ronald Reagan Elementary. There you go, nicely done. Nice round of applause for you guys. I know it's me in here and making the kids, but nicely done. So I know there are some other Do the Math shows and math programs all around the world, but Do the Math is the one with its own symphony now. You guys are the beginning of this. So how long have you taken to practice this piece?
About 3 weeks.
A couple of weeks, you guys work together, you've got it. Where are you able to go as part of your Strolling Strings program?
You can go to Knott's Berry Farm as a merit trip, kind of.
Okay.
And
So
and you can go to other concerts. Like we went to the Robobank or Mechanics Bank now.
Right.
And we played in the lobby.
Oh, good. So you guys have an opportunity to go out and practice your skills and get exposure. And I mean, you guys plan on this being part of a major part of a career later on, or is this just something that you guys like to do and it's fun to be musically inclined?
To me, it's fun to be, yeah.
Well, that's all you want it to be right now, is have fun with it, right?
Yeah.
Well, we certainly do appreciate you guys taking out some time to come and visit us this afternoon. That was awesome. I can't thank you guys enough. We have never had, in 20 years, 4 kids come in here, play musical instruments, and especially as well as you guys have done that. That was astounding and fantastic that you guys were able to do that. All right? So thank you once again, all 6th graders, right? From Ronald Reagan Elementary, and I'm sure you guys will continue to play next year when you're in junior high also, right? All right, nicely done. Hey, we'll be back with more right after this.
If all of the ice in the Arctic Circle were to melt, life for Arctic animals and for people all over the world would be dramatically different, and not in a good way. That is why measuring how much is there, how thick it is, and how fast the ice is melting, both on land and in the ocean, is so crucial for understanding what is happening in a changing Arctic. It's a challenge to make ice measurements in the unbelievably harsh environment of the polar regions. Scientists can reach the ice by boat or plane to make on-site or in-situ measurements, and satellites, aircraft, and buoys can take readings remotely. Since 1979, scientists have been using satellite images to create an outline of the dimensions of sea and land ice. And since it's not just the area of ice that matters, but the thickness, satellites do that too. Some satellites measure small changes in gravity that reveal where ice sheets are losing mass, while others use lasers to measure the height of ice above the land. To understand how fast sea ice is melting, scientists put underwater buoys called moorings at strategic locations in the Arctic. Moorings are especially good for calculating how much warm water is flowing north into the region. Devices are attached to the moorings that collect data on temperature, salinity, nutrients, currents, and the thickness of the ice above it. Scientists also use manned and unmanned aircraft systems. The aircraft carry the latest measurement technology, atmospheric temperature and pressure sensors, ice surface temperature sensors, gravimeters, and laser rangefinders. The data collected from these instruments allow researchers to create 3D digital elevation models, which help calculate the thickness of the ice sheet. By putting all of this information together, scientists can get a more accurate picture of how Arctic ice is changing both on the land and in the ocean. Animals of the ice need sea ice to survive. Across the polar food web, sea ice loss and warming seas mean massive changes for them. Some are finding their food sources disappearing, some are losing habitat, and almost all are feeling disturbances to the patterns of their lives. The loss of sea ice is already affecting polar bears. Their main prey, ringed seals, live under it, and bears hunt from the ice above. As sea ice shrinks, bears are having to swim further and further to get to their food source. The harder they have to work, the fewer will survive. Sea ice loss will also cause ripple effects that people will feel across the planet. Rising sea levels are a concern for all coastal communities. The loss of sea ice itself does not directly cause sea levels to rise, but sea ice has another effect on the climate which can. Because it's highly reflective, sea ice sends a large amount of the sun's heat back out into the atmosphere. With sea ice gone, more of that heat stays to warm the ocean and the land. And land ice melt does raise sea levels. If Greenland's ice sheet, the largest in the Arctic, were to melt, it could raise global sea levels by more than 20 feet. The addition of huge amounts of cold, fresh water will also affect the ocean's currents and even atmospheric patterns like the jet stream. This could lead to more extreme weather events all around the world. Sea ice is important for animals and people. The poles and their ice are part of the interconnected climate system of our planet. Changes there affect us here. But like so many other parts of the global climate, what happens to sea ice is affected by what we do. If we make changes to our lifestyle, we can still help preserve polar ice and the animals that call it home.
And once again, we are wrapping up our 20th season. Today is the last live broadcast for Do the Math for season 20. Shaun and Zain, 6th grade students from Old River Elementary, in studio with us, and Mick is one side, I'm on the other side. You guys have some logic problems that you're going to work on right now, all right?
Yes.
So, it says for you, you've got 2 red, 1 orange, 1 yellow, 1 green, 1 blue, 1 purple, 1 white, and 1 black, and you have a bunch of things you need to do, right? You each have a different card, all right? So you guys have your tokens out based on the color, and what you want to do is go ahead and read through the clues, place the colors where they need to be. I've got the keys, and it's kind of like a friendly competition between brothers, let's say.
All right, yeah.
So, are you guys ready?
Mm-hmm.
On your mark, get set, go.
Okay.
All right, where do you want to start?
So if
So
the white
what's
chips
the
are on the
first thing
same
you're
row,
reading?
this is both red chips are on the bottom row.
All right, so you have to put both red on the bottom.
This is CH right there.
Just try it for now.
Yeah.
Keep
Yeah.
going.
So this is the black chip is not on the left. So
The black is not on the
orange
left.
could be
All
right there, I guess. The black chip and the yellow chip are in the same row, but do not touch.
One
So
of
that
these
could be in between
a white or a black.
Okay.
That means it could be like that.
Okay, it could be.
The orange chip is
The
not on
purple
the same
chip is-
row as the white chip.
The purple chip is directly
So
to
I'll
the
be with
right
the
of the
black
red
then.
chip.
Okay.
So I think the bottom row might be
Do you
right.
think that's all right? All right, keep
The blue
going.
chip
Yeah.
is directly below the
The
white chip
is
on the
directly
left side. So there's a white
above
chip
a
on the
red
left,
chip. So this is put
and there's
right
a
there.
blue under it.
The orange
So it
chip is
could
on
be
the
like
right.
this or this.
Could be
Okay.
right here. The yellow chip is directly below
It'd be
the
like
blue
this
chip.
because then a white has to be in
we
the
gotta
same.
move
Oh
yellow,
wait, no,
right?
it could go this
So
way
then-
too, or that
Okay,
way.
but they don't touch, right?
Yeah, yeah.
White chips do
So how are
not
you guys
touch.
doing over there?
So if the white one was there, where would the other white one have to
The
go?
green
They're
chip.
the
You're in the
same
lead,
row
at least
and
you've got
don't
colors
touch.
on there now, right?
It
Yeah.
can either go here,
Okay, so I
here,
got
or
something.
here.
Both red chips
Same
on the
row.
bottom. Black chip is not on the left.
Oh,
Black
okay.
and yellow chip
So
do
where
not
could that white
touch.
one go?
Right here?
Directly to the
Or-
right.
This would be a column. The rows are going to go
Above.
left, right, columns are up and
Oh.
down. You're
To the
good.
right.
Okay, so right here.
Okay, let's go back to clue number 2.
Did I just
So
get
do you
it?
The
think
black
this
chips
works?
on the same
think
row.
so.
Let's take a look at each
So it
one,
has to be
all right?
in
So I
here.
don't know if
Alright.
the camera can see the colors exactly, all
It's
right?
gonna
It
have to
says
be like this, right?
both
Okay.
red are on the bottom.
And then
Do we have both red
the
on the
orange chip
bottom?
and the green
right here.
chip are in the
Black
same
is
column.
not on the left.
But
This
do not
is
touch.
the left for me. So yeah,
Okay,
right
so
here.
where
they're
do
in
you
the
think they're
same-
The
good?
black
gonna be in
and
the middle
yellow
somewhere.
are on the same
Okay.
row, but do not touch.
Yes, like
Very
that.
good.
The orange chip is
Purple
not on the
is
same row as
directly
the
to the
white
right
chips.
of red.
There we go.
Which is
Then
right
right
here.
White is directly above
Wait, the green
red.
chip are on these
Okay,
right
so
here.
that would be there.
Orange is on the right.
So
She's on the right.
Right.
Yellow
of
is directly below
Oh,
blue.
we got it then, right?
Which is right.
Boom, there it is.
Green is on the top row.
Yeah, like that.
Good. Let's take a look at yours.
Yeah, well,
All
I
right,
don't
so
know. there,
read
yeah.
through them. Go ahead.
All right, so the white chips are in the same row but do not touch, so we have them in the top row. Clue number 2, the black chips are in the same row but do not touch. They're in the third row. The orange chip and green chip are in the same column in the middle but do not touch. The orange chip is not in the same row as the white chips. It's in the bottom. The white ones are in the top. The blue chip is directly below the white chip on the left side. That is correct. The yellow chip is directly to the right of the red chip. Bada bing, bada boom. And number 7, neither white chip touches a black chip. White ones are in the top row. Black ones are in the third row. We are good to go.
All right. You were good to go also, right?
Yeah,
So who do you
actually.
think won?
I don't know.
I think it was a tie.
Yeah.
Oh, I think
You guys
paper, rock,
both?
scissors will settle this.
Easy with the paper, rock, scissors. I think we read his first, so I'm going to say that he declared the winner.
Oh, just because the host can read first. I don't know
Now,
about
that's
that.
one of the privileges you have. But you guys, I think that was a draw, right? Because you guys
Yeah.
both finished at the same time. We just happened to read one before the other one. So did you guys like doing that kind of a problem, right?
Yeah, these are
Just a
fun.
little bit of a logic problem right there. All right, nicely done by both of you.
Thank you.
Well, as I said, we are celebrating our 20th season on Do the Math this year, and all during this season, we have had the opportunity to go out and every single week bring you a feature of a different industry or different company and see how they apply math. Let's take a look at some.
Some
amazing here at Baker's Outpost, and we want to know a little bit more about Baker's math.
Once I graduated, they got me enrolled into their one-year apprenticeship program. They set me up with one of their master techs, supplied tools.
You can see that the color on these are a very dark purple. And we can pick these today. We can come through, because we are picking them by hand. We can pick these today, and we might want to leave some of the light purple or even the green ones.
It's okay if it takes a couple of tries.
We burn about 23 gallons of fuel an hour, and that's in a cruise condition. We can burn up to 28 if we're in a hurry. So depending on how much demand we're putting on the engine,
Right.
if we're trying to get to a call in a hurry, we can burn up to 28 gallons.
So about 3 hours in the air, and you got to go back and start looking for some refueling options. Right?
Usually about 2 hours is when our bodies are pretty much done.
And 4 of those land grants, Rancho El Tejon, Rancho de Castac, Rancho La Liebre, and Rancho Los Alamos de Agua Caliente, were all put together by General Edward Fitzgerald Beale in the late 1850s and 1860s to comprise what he called Ranchos El Tejon.
Okay.
And so this is Shenette Creek, but we're higher up in the watershed now. So if you look at the creek and the way it is, and if you take a look at the vegetation here relative to where we were previously, the creek is deeper, it's actively flowing, the vegetation is larger, it's more robust here.
So a normal cadet would spend probably 10 to 15 hours in a link trainer as part of their training while they were here.
So this is an actual trainer for pilots on how to fly.
Yes.
Previously, when we were here the other day, and we saw that military vehicle and all the brand new hoses, those were all spec'd and made up in here?
Yes, Anthony built all those hoses.
Wow, so even something as necessary and as strong and as powerful as something for the military is made right in here.
That actually serves a very valuable purpose. The timing at the racetrack is light beams that go across, across the track, okay? And that serves to break that beam. That's what gives us the indication of timing at different points on the racetrack. That lets us put the car exactly on the starting line.
The DNA is negatively charged, so it's going to move towards the positive side, and that's like a magnet. There's an attraction that's going to pull it towards there so we can look at that band length.
So we really look at this rate to see, well, what are people buying? What is a way that we can do better to maybe encourage a little bit more buying, or the better quality of buying? Are they coming to just buy a t-shirt, or are they coming to buy t-shirts for the whole family? So it really helps us navigate, hey, what are we doing right and what are we doing wrong?
And once again, big thanks to all of the different businesses that allowed Do the Math to come out and learn a little bit more about what they do and how they apply math in what they do. We are wrapping up season 20. We've got Shaun and Zain, 6th grade boys from Old River, share the same classroom, have been for many years. Looking forward to maybe doing some different classes in junior high though, right?
Yeah.
All right, well, you know what? Speaking of 20 years ago, they had an idea for Do the Math and the set. So they had to have an idea of what is this thing going to look like, and this is what they came up with before you see what you see now. So there it is, and you can see not all of that here.
It's pretty close. I would say it's closer than it is off.
Right, because I mean, from where I stand, it doesn't look like that to me, but I'm looking with everything in back of me.
The rest of us looking at you, you match pretty well.
Right, everybody else goes, oh yeah, and there it is, right? So it does match pretty close to what they thought 20 years ago. Things have been updated. The lovely whiteboard that we had for many, many years is now on the side as an emergency.
Smart board here.
And we've gone through different iterations of those as well. Some that have worked better and some that have not. But anyway, we're going to use the best smart board that we have right now and have the boys work once again. So boys, head on over to the board and each of you grab your markers, and we still have that line down the middle, so you need to work on a side. So what I'd like you to do is, you said that in 6th grade you were working on input-output kinds of things where they give you a problem and you have to know how to write it out.
Pretty much, yeah.
Okay. So Shaun, why don't you come up with one right now and kind of explain to Mickey what you guys are doing in class, the best you can.
Okay.
All right.
So it might not be perfect, but pretty much you would say maybe like Tom goes to the store to buy apples, And can I write something?
Yeah, whatever you need.
So this would be the total cost of what he's buying. That would equal blank times blank. So if he's going to buy, let's say 3 packs, so this would be packs, and then you would buy 3. You have to solve that and to know how many packs he bought.
Okay. Now what if I took it a step further and said, okay, you know, we do have a total cost here. If I can wake up my board. There we go. So we do have a total cost, right? Mm-hmm. That's the money we're going to spend. And I say, okay, he's going to buy P amount of packs, right?
Yeah.
But now I'm going to throw in there, each pack is $3. Yeah. So I want to know, what will the total be, right? If I tell you he's going to buy 12 packs. Walk me through, how would you solve that, our input, and what would our output be?
Okay, so our input would be P, and our output would be T. But to solve for P, just rewrite this question to T equals 12 times $3. So that would be the equation. This is the output, this is the input.
Okay.
And so what you're going to want to do if you want to solve this, you would do 12 times 3. Don't worry about the money. So that would just equal 36. So then T would equal 36, and then you have to add that $1. So yeah, the T equals 36. So that would be the total cost. He would spend $36 if he bought 12 packs.
Do you agree with your brother?
Yeah, I agree. Yeah.
Okay, he's doing okay. We're not going to tell him he needs to fix it. He's pretty good?
Yeah.
Okay,
seems like it.
So Zain, I'm going to give you a minute. Come up with one also.
Okay. So should I explain what?
Yeah, go ahead and tell me, kind of give me a real world scenario and what would it look like mathematically?
Okay, so let's say that you are buying a lot of oranges. And
I love the oranges.
So
I love it.
This is, I guess I'll put Z for the total cost.
Okay.
And then you would do this is the total cost, and each orange costs $5. So you would say 5 times the amount of oranges you get. That's a bad. There you go. So then you would need to find how much
I want
each.
8 oranges.
8 oranges.
Okay.
He's making orange juice. Let's give the man 8 oranges. How much money would he need to buy those 8 oranges then?
So since we know that O equals 8, we could rewrite this as Z equals 5 times 8. And we know that 5 times 8 is 40. Well, that's bad 4. Is 40. So then we could do Z equals 40. So the total would equal 40.
There you go. Nicely done. So boys, come on up here for a quick minute. So, did you guys learn a little something today?
I did, yeah. Yes.
Did you have some fun on the show today?
Yes, it was
That's the bigger thing right there. So Mick, did you learn a little something today?
I did, yes. I didn't realize nearly as much knowledge as I thought about string instruments.
There you go. Did you have fun today?
Always.
That's what we're always looking for.
Did you have fun today?
Hey, I always have fun on the show. 20 years, I'm still
look at
having
that.
fun
John's
on
coming
the
in
show.
from the background and putting a little
There
input
you
into
go.
the show.
You know what? We are wrapping up our 20th season here on Do the Math, and we want to thank everybody that is associated with the program, people that sponsor us, people that just help us keep this thing going, and especially people at the Kern County Superintendent of Schools office for implementing this program and allowing us to keep it going. Until we meet again in September of next year, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.